Hey, welcome back to Gold Scratch. So this is episode 3 in the build of Paul's 355 cubic inch engine that we're putting a brand new Eagle rotating assembly in. And so in the first 2 videos that we made, if you're interested in, we started from scratch when we brought the block back from the machine shop. All the preparations in the block, putting the camshaft bearings in and oil plugs and all that stuff. So that's in previous videos. So today we're going to talk about, the subject is going to be, what is the difference between blueprinting and assembling? And the word blueprinting gets thrown around and abused and misused a lot. And so for what it's worth, here's where it came from. In the early days, before I forget, Alex, please like and subscribe and share, comment, give me your comments. We're learning from your comments. So in the early days of engineering, and I'm talking early 1900s, drawings were made on a piece of paper with a set square and a drawing board, but they had to be reproduced, right? You couldn't just have one copy of it. So the paper they put on it was called a mylar, reproducible, and when it was copied to another piece of paper, the paper was blue and the lines were white in the early drawings. And that's how old I am. I actually worked on drawings like that. So, because I was trained in the days before computers, right? So anyway, that's just a little tidbit for you. So, but blueprinting in the sense of, as you apply it to building an engine, one of the differences is, if you are blueprinting it, you need to accurately measure all the important dimensions, and we're going to demonstrate how to do that today. We're going to do bearing clearance, piston to cylinder wall clearance, end thrust, piston deck height, and a few other things, and demonstrate not just what it is, but how to use the tools to measure that, including a micrometer, dial bore gauge, etc. So, but what's the point of it? Because I'll give you a little preview. This Eagle rotating assembly we bought from them came in a big box complete. Rings, bearings, pistons, crankshaft, rods, all that stuff. And listen carefully. If I'd have put that together just as it came out of the box and did not measure anything, it would have run fine. Now, I can say that now because I did measure it. I would never ever think of doing that, and you shouldn't either. You should always measure, and that's the difference between blueprinting and assembling, just putting it together. Now, if you're putting it together, you trust your machinist and you got the right size bearings and all that, most of the time you'll be okay. Very few times we make changes, but this, in this case, is an example of where we are going to make changes because I'm not happy with the numbers. So we're going to put a screenshot up of all the dimensions that I've taken already. Piston cylinder wall clearance for every piston, main bearing clearance, rod bearing clearance, end thrust, deck height, all that kind of stuff. And show you that in the case of the main bearings, I'm going to make a change, and here's why. So the main bearing clearances, to use a term, and I've heard other guys call this, Eagle crankshafts are big or tight, if you want to use that term. They're built on the high end of the manufacturer's tolerance. And Mike will put a screenshot up to show you exactly what I mean. And in a second, when I get done talking here, Alex is going to come in and show you what I have on the board here. So how do I know that? So you go back to your manual, okay, and it shows you the range, or tolerance is the range of sizes that it could be and be in specifications. So there's always a minimum size and a maximum size. And in this display that we have, we're going to show the GM specification, minimum and maximum, okay? And that is a tolerance. The clearance is the difference between, in the case of a rod bearing, the difference between the inside diameter of the rod with the bearing in it and the outside diameter of the crankshaft. That's your clearance. But there's also a tolerance for that. in terms of how much clearance could be. What is the range of clearance that's acceptable according to the GM manual? Now, just to use a connecting rod bearing, for example, the minimum clearance for a connecting rod bearing is 0.0007, 7/10 of a thousandth of an inch, not even 1/1000th of an inch. And so for relativity, human hair is 4/1000th of an inch. So that's not even a quarter of, it's more like a fifth of the clearance of the size of a human hair. So it's not very much. So why is that important? So I'm going to have Mike to come in, Alex come in and show you. There's the difference between a high clearance and a low clearance. And what happens is, typically it's safer to be on the high side as long as you're in tolerance on your clearances, because you're less likely under severe conditions, maybe your engine gets hot or unduly loaded or detonation or whatever else. If you're on the tight side, then that's your crankshaft journal, right? And that's your bearing, and that's the oil clearance in between. If you're on the tight side and the bearing, the shaft starts running on the bearing, it's going to seize itself to it and spin a bearing, and you're going to have a bad day. So make your clearances high, right? That's okay. But you got to be within spec still, because here's what happens. When you got a high clearance, look at the size. The red part is the oil film in between the bearing and the crankshaft. So if you have a high clearance, the difference in the diameter of the journal is, compared to the diameter of the bearing, is more, and so you're going to have a shorter oil film. If you have a low clearance, a tight clearance, then that oil film is a lot longer and your shaft is supported better. So don't go crazy putting too much clearance in it. Once again, the clearances, maybe if you come back in here, Alec, for a sec, sorry. Just to show you, this is just the main bearings I took. So I took an average, and that average includes the rear main, which is always different. But the average clearance that I measured, the average size of the crankshaft, the Eagle crankshaft, was 2.4495. And go to the GM spec, right out of the manual, okay, minimum and maximum. The average and the high side is 2.4492. So on average, this crankshaft is 3/10 of a thousandth bigger than the maximum size, okay? Then you go to your clearances, okay? So same thing, same journals. So that's what I actually measured, 21, 16, 20, 121, I mean 2.1 thou, 1.6 thou, 2.0 thou, etc. So the average was 1.8 thousandths of an inch, okay? So on the GM spec, it could be as tight as 1/1000th of an inch, or as big as 2.3 thousandths of an inch. So since we're 1.8, the average is actually under the GM specification by 4 thousandths. But for performance application, typically we like a little more. I like to have my main bearings minimum of 2 thousandths. A lot of racers where you're using the engine a lot go even higher than that. 2 to 3 thousandths I think is good judgment for your main bearings. So how are we going to do that? I'm going to do that by, I've already ordered another set of bearings that have a 1/1000th of an inch extra oil clearance. So the bearings are 1/1000th of an inch bigger, two together. So each one is 1/2 thousandths. So what I'm planning to do when I get them is go through the same process, only I'm going to install a half of the extra oil clearance bearing with the other half of the standard bearing. I'll gain a 1/2 thou. So if my average is 1.8, my average should come out at 2.3, and we'll follow this up. I don't have the bearings yet. When we get them, we'll follow this up and show you what the outcome is. So once again, if I just installed the bearings the way they came, they would have been fine. The engine would have started and run fine. But I do like to have a little more main bearing clearance. I'm going to get my main bearing clearance up to over 2 thousandths of an inch. 2 to 3 thousandths is a good number. For the rear main is usually a little more. And that's what drives those averages up. When Mike puts a screenshot, you can see closer. The rear main is usually more because the bearing is wider, right? So there's more to support there. So the rear main's usually, I don't know, half a thou looser than the rest of the bearing. So that's the story. So that's the difference between blueprinting and assembling. Blueprinting, you take all these measurements, you document them. Now I start by just writing them down in a notepad, and then I transfer them to a computer. I have a database for every engine I've ever built, but you don't have to do that. If you write them down, document it, and you know what you got, compare them to the manufacturer specification or to where you want to go, what you want to have for clearance. Some guys like to use even more than that, but there's lots of OEM engines running around with less than a 1,007-inch bearing clearance, and they're doing just fine. So that's the difference between blueprinting and assembling. You check everything, you document everything, and when you document it, you don't just put it in a book and forget about it. You look at the numbers and say, do I need to make a change here? How do I do that? One of the options that you have, if you didn't use the bearing option, you take it back to your machine shop and you have them grind it a little tighter for you. But this is a brand new crankshaft from Eagle. I sure don't want to be doing that. And the half thou, I've done this many times. Now, some people worry what happens when the bearings come together in the half. So I'm going to, because it's the only thing I can do is use a rod bearing to show you. If Alec wants to come in closer. The dimension check is always across parallel to the length of the rod at the very center, because the bearings are actually a little wider right here. Where they come to the parting line, the bearings are actually a little wider. So why is that? That's to allow what's called an oil wedge for the oil to get in there and get compressed as the crankshaft rotates to help support the crankshaft. So ideally, you never should have your crankshaft rubbing on these surfaces. If you wear out a bearing, it'll almost always be at the bottom and the top, and the most will be right at the center. So hopefully that explains clearances, what we're after, and what's important. And we'll follow up, because when I get those bearings, I'm going to install them, and we're going to take new measurements and put a screenshot up of a document comparing before and after, and you can decide. If I didn't do it, the engine would run fine. So I'm going to shut down right now for a second and get set up and show you a clip of taking some measurements. Okay, welcome back. So what we're going to do next for you is we're going to measure the piston to cylinder wall clearance, actual piston to cylinder wall clearance, using a micrometer and dial bore gauge. Now, as I just mentioned, if you're blueprinting, you got to measure everything, and you got to know what those measurements are and how they compare to what's ideal or what the manufacturer specification or whatever you're trying to accomplish. So one of the things about a dial bore gauge and a micrometer is, I guess there's a couple impediments to doing that, is they cost a little bit of money, but a lot less, relatively speaking, than they used to be. This is not an expensive one, but 1,007-inch is 1,007-inch. It still works fine. And micrometer sets as well. If you don't want to buy a whole set, if you have a 2 to 3, you got all the bearings covered. And if you have 4 to 5, you probably got most pistons covered. So those are the 2 that you need most of the time. Okay, so we're going to show you determine the piston to cylinder wall clearance for number 3 cylinder. And I'm going to show you how to read the micrometer, transfer that to a dial bore gauge, and then measure the clearance. So first of all, a dial bore gauge for measuring a piston, it comes with adjustable or a variety of plungers, and I can change those little plungers in here, or this spacer can come out for just a bearing or whatever. I would take this black part right out, but it covers the whole range of, I think, right up to 6-inch bearings. So you just have to kind of change the extensions just to get it right. So what we're going to do is, first of all, measure the piston. So one thing to note, this is a coated piston, and as you've know already, if you watch my videos, read all the instructions, okay, because they'll tell you lots of stuff that I'm telling you, but one of the things is when you measure a coated piston, they give you a couple little dots, and the piston, you always measure it 90 degrees to the pin, okay, and at the center, and always near the bottom of the barrel. Essentially, you want to measure at the widest part of the piston, and the piston is not totally cylindrical. It's got a taper to it, okay? So that's where we're going to measure. And the difference would be that coating is about 1/1000 of an inch thick. So if I measured it on the coating, I would be off by that much. So if you measured the instructions, they would have told you that. And so we're going to show you, first of all, I got my micrometer set up. It's a 4 to 5 inch micrometer. So nominally, this is a 4-inch bore, 30 over, 4.030. Nominal numbers would be 4.030. And we are going to put up another screenshot of even the piston, the cylinder wall clearance. So you see these numbers on there as well. So to take a measurement, it takes a little feel for you. So you want to get you right in there. And it takes a little practice to do it. You just want to just lightly touch it as you go by. If you have to force your micrometer, but you always have to make sure you move it this way as well to make sure you don't bind it up. And you just want to touch it. You don't want it to be impeding your travel at all if you're in the right place. Okay, so I'm pretty comfortable with that. And so once you got a number that's you feel you got the right gauge on it, let's try to read the micrometer together. So it's a 4 to 5 inch micrometer. I gotta grab a pen here. So at the beginning, if it's 4 to 5 inch, then that's the 4-inch line. So every rotation of the thimble is 25 thousandths. So these little marks here are thousandths of an inch apart. So every rotation is 1,000. So I'm past the first 25. So that's 4. And then 25 thousandths there, and then the 25 thousandths ends at the 0, so you keep counting, 26, 27, 28, so that's 3 more thousandths. And then for the tenths of a thousandths, you're trying to measure a tenth of a thousandths of an inch. So we've got to turn it up and look at the vernier scale. Can you see that, Alec?
Yeah.
Okay. So this is the vernier scale here on this side. So whatever number on this side, this is your tenths of a thousandths of an inch, lines up with a line on the other side, okay, is the one you want. So from here, it looks like 5. So that's 5 tenths of a thou. So we got 4 inches plus 25 thousandths of an inch plus 3 thousandths plus 5 tenths of a thousandth. So let's look at a little chart, okay. Started off with a 4-inch mic. One notch is 25 thou. It was 3 thou more than that. And then the number that lined up was a 5. So you add all that up, it's 4.0285. So nominally it's 4.030. So the pistons typically are a little bit smaller. And that's how you get your piston clearance. Okay, so now that we have that, what are we going to do with it? Well, I've got to transfer this dimension to my dial bore gauge. And then it will tell me when I'm transferring it. When I'm doing that, it'll tell me when I get done, my dial bore gauge 0 will be exactly the same size as the piston is because it's on the micrometer. So this takes a little bit of feel, but one of the things you have to do if you're not used to doing this, it's like everything else. It's not as hard as it looks. You just got to practice it a little bit. So I got to get this zeroed as much as close as I can. So you're just trying to find the widest spot. And fumbling around a little bit today, but okay, close enough. So I'm zeroing my dial bore gauge. So now when that dial bore gauge is back to 0, it's exactly the same size as the piston. So now it doesn't really matter what this size is. What matters is how much clearance you have. And that's the beauty of a dial bore gauge. It only measures clearance. So now we're going to go over here, and if Alec can follow me, and put the dial bore gauge into the cylinder. That's number 3 piston, so we're going to put it into the cylinder. Can you come around this side, Albert? Because the gauge is on this side. So we just slide it into that space and rotate it, and we have just over 2,007-inch clearance. See that? Camera can probably see it better than I can here. Anyway, so wherever that stops going up, as long as you always put your dial bore gauge in. 1, 2, that's 2,000. There you go. Okay, now this is a brand new cylinder. If you want to measure a taper in the cylinder, you can try doing that at various places and see if you got any taper. It better not have, because it's a brand new bore, right? So I'm pretty sure that the cylinder will be decided. Typically you measure down 1 inch or so from the top. You want to get away from the very top of the cylinder when you measure it. And if you have a used engine, used bore, you want to get down away from once again, the top of the travel of the rings, and to take that measurement. So for purposes of demonstration, I couldn't see the number very good myself, but it looks like about 2,000 from where I was. And so we document all that. So what's the right clearance? That is the correct clearance for a hypereutectic piston. I've done them all already, and we'll put the screenshot up. I think they're all between 2,000 and 2,500. So the same process is used for whether you're doing a main bearing or a rod bearing or a cylinder. It's the same thing. You measure it with a micrometer, you transfer that measurement to your dial bore gauge, and you go in and measure. Ultimately, you're measuring the space that which tells you how much oil clearance you have. Now, if you haven't done it before, one of the things you need to do is practice a little bit till you have a good feel. And one of the ways you can find out if you're getting it is repeatability. If you take a set of measurements, okay, and just for example, because I already mentioned we're going to change the main bearings in this engine, I took all the measurements a couple days ago. I looked at them on my computer. They're close. I wanted to be sure. I went out and I took the exact same measurements again without looking at what I had done the day before, and every measurement was within 0.1 tenths of a thousandth of an inch, a tenth of a thousandth of an inch. So you can do that too. It's not that hard. It takes a little practice, a little feel for it. Take your time. It's not something you want to rush when you document that. So we've covered that off. We are going to shut down again and set up to show you taking thrust clearance and deck height. I'm going to show you a couple more things, checking end thrust and deck height and a few other things, but a couple comments first. For all those that commented the last video, and there could have been some before that, I can't remember, we had a problem with lighting, with backlighting, and lots of guys give me advice and comments. We got the camera fixed. It was the camera's problem. We did all kinds of stuff here trying to block out light, and it didn't really help. It was the issue with the camera. We got it fixed, and hopefully going forward we'll have better quality videos for you. So anyway, one of the other things is we're showing you how we just looked at a dial bore gauge, a micrometer, now a dial indicator. Here's a tool that if you're going to build any engine, at least more than one for sure, you want to get for you. They're not that expensive compared to what your engine costs, that's for sure. They're not that expensive, but if you want to build a blueprint and engine, you have to be able to measure with precision, and you can't do it without good tools. So we are going to use dial indicator to measure thrust clearance. So what is thrust clearance? So the thrust bearing, and this is the thrust bearing, the one that we're measuring is under the main cap already, okay? But the thrust bearing controls the fore and aft movement of the crankshaft, okay? And that's pretty important. And so how it does that, here is another thrust bearing, exactly like the one that's in there. It goes around the crankshaft, of course. And these two surfaces on each side, one bears against the block and the other bears against the flange on the crankshaft. And that controls the fore and aft movement. So the specification for it is 3 thousandths to 11 thousandths in the GM manual. And typically with a new bearing, it'll be closer to the tighter side. And I don't know if I'd even want to use one with 11 thousandths, but typically you start off and the minimum is 3 thousandths of an inch. So we're going to measure that for you in this little clip and show you why it's important. Now, yeah, let's measure it first, Alec. And so Alec's going to come in here. I just got to find, I got my tool on the 0. So now I'm just going to force the crankshaft with a screwdriver the other direction. And there's 4 thousandths of an inch. So, okay, we can come back. Okay. So that means the crankshaft can go back and forth in the block 4 thousandths of an inch. And that's a good number. We're happy with that. Now, what if we weren't happy at that? And if it was less than 3 thousandths, I would take that bearing back out, and you can do that, slide it back out, and take this surface, clamp it together with a hose clamp or something like that, put it on a flat plate with like glass or something very flat, and find sandpaper or ME paper, and just maybe take yourself a couple thou off or whatever you need to get the thrust clearance that you need. Now, what does thrust clearance do? Keeps your crankshaft there, but one of the things it's there for too is, if especially you have a standard transmission, every time you step on the clutch, you're pushing on the back of the crankshaft, on the flywheel, that pushes on the back of the crankshaft, and it's pushing on that flange. So one tip of the day, when you go to start your car, start it in neutral. Don't start it in gear with your foot on the clutch, because that surface is going to be dry when you go to start it, and it's not going to get it oil till you get it going. So, and spend as little time with your foot on the clutch as possible, because whenever you're doing that, you are putting a force. Now, if it's lubricated right, it'll probably last as long as everything else will, but if you want to take care of it, once again, try not to abuse that any more than you have to. So that's one tip. So while we're at tips of the day, here's another one that in the previous video, when I was putting thrust plugs in, or freeze plugs, or core plugs, I got to make a comment about that. I just put some of this on this surface, and I just called it goop. Somebody asked me what it was. That was pretty dumb of me to call it goop. I know better than that. So it is Permatex thread sealant. Okay, there's actually a number 80634. There's different products that you can use to seal things like this, and oil plugs, etc. I also use this for sealing the head bolts. When we get to that, the head bolts on a small block Chev go into water, so they got to be sealed as well. You just can't bolt them in, and this is the product that I use. It's worked pretty well for me, so it doesn't take very much. A bottle like this lasts quite a few engines, so let's cover that off. So that is thrust clearance. We're going to get set up and show you the deck height and why that's important in the next clip. Okay, next we're going to show measuring deck height. So what's deck height? Deck height is the difference from the top of the piston to the surface of the block. Okay, how far the piston is, so to speak, down the hole. And so why is that important? It affects a couple things. First of all, when we start this engine, we don't just start putting parts in it, we design it. And we need to design what the proper quench height is. What's quench height? It's the difference between the top of the piston and the bottom of the cylinder head. So deck height is part of that. The other part is the thickness of your head gasket. So your head gasket gives you the ability, sometimes anyways, to adjust your quench by using different thicknesses of a head gasket. That's part of designing it. So one of the things you do, we don't just get parts to start putting them together. We mock it up. So right now this piston is in here with no piston rings on it. It makes it easy to work on. I could just as easily put it in that piston in any hole, it doesn't matter, and take measurements. And this will all come back apart, and before we do the final assembly, we clean the parts, etc. Go ahead. So measuring deck height, in this case, the rotating assembly that we bought from Eagle, the pistons, the compression height of the piston, which is the distance between the center of the pin and the top of the piston. That's compression height. That compression height is actually 20 thousandths shorter than standard for whatever reason. I don't understand why they do that. Maybe somebody knows why they do that. So to get the proper quench, we need to get it back to standard because we are using cast iron heads, cast iron cylinder heads, OEM heads. We can use a stainless steel head gasket. That's what the original engines came with 50 years ago. A stainless steel head gasket, and we used to paint it with silver stove paint or something like that. I will show you how we do that now. But in order to get the right quench, the cylinder deck height from OEM was about 25 thousandths. Add 15 thousandths for your head gasket, you got 40 thousandths, which is an ideal quench number, 040, the distance from the top of the piston to the bottom of the cylinder head. So we need to make sure we get that right. So because I going back to some of my previous videos, read the instructions. When you look at part numbers, understand the part numbers, and part of the part number for that rotating assembly is the compression height of the piston. So that was what triggered that tip that sent me off looking at finding that out. So we had the block deck 20 thousandths. So if I hadn't done that, the piston would be 45 thousandths down the hole. So by decking the block 20 thousandths, we're hoping to get it 25 thousandths down the hole. Add 15 for the gasket, and you got 40, and you're good to go. So let's see how much it is. Alex is going to come in here and measure it. So this is the same dial indicator I just used. It gets a lot of use for a lot of different things with the bridge. There's a number of ways. I also have a depth mic, which you can use to do that. So I've zeroed it. If you look at where the zero is, you first of all, you have to make sure you know where top dead center is. So let's just show you that. See it? Okay, can I come back up now? Okay, there it is. So right now the dial indicator is zeroed. So if I move it over to where the deck is, it'll tell me how much the piston is down the hole. So I just take it, move it over. And actually that's coming out about 28 or 29,000, which is a little more. Maybe a couple other places it might be a little better. That one's 28 or 29. Maybe I didn't get it all quick because I did measure this before I had 27. So anyway, that's how you do that. Yeah, my number is off here a little bit, Alex. So let me just change that. Try it again. There you go. That's a little better, 27 thousandths. I was off a little bit on my zero. Anyway, once again, this example you just saw, if you don't get the result you want, you have to remeasure because maybe you didn't measure it right. So you keep measuring until you're confident you got the right number and it's a number that you can go with. So I'm trying to do this fast for just demonstration purposes. We're aiming for 25. I think I've checked a few other spots. It's more like 27. Close enough, okay? So because we took 20 thou off this deck, there is a little bit of variation. 9025 is the standard height from the top of the deck to the center line of the crankshaft. So when we're demonstrating stuff, I'm showing you checking one piston or one bearing or whatever. But when you're doing it, if you're assembling your engine, first of all, you start with a clean bench. It's a little bit cluttered because I'm trying to show you stuff. But if you're going to do any processes, for example, before I check clearances, I got to torque all these bolts to specification and the connecting rods before I can measure them. So I get set up and I do every one at once. 1, 2, 3, 4, 6, 7, 8. And that way, and then when you put the rings on, you do the same thing. Any process, try to think about, if you were at McKinnon Industries or the Flint assembly plant back in the day, how you would have done this. You wouldn't do all the processes to one piston and then go look for the other piston. You do all the process to all the pistons, and while you got your setup there, you're less likely to forget things, less likely to lose things. Lay stuff out clearly so you can see what you're doing. Hope you found that helpful. I think we're coming to the end of this video. Hope you stuck with me. Thank you very much.
What's next?
Yeah, so next we're going to do, and for those experienced builders that watch this, if you stuck with me, thank you very much. I know you know all this stuff and more. But we're trying to help guys who, based on the comments I'm getting on my channel, a lot of comments of guys, I'm building my first engine and I'm looking for information. That's what we're trying to basically satisfy. So we're going to make a number of videos. So where we're at with this engine right now, I mentioned already, we're going to change the main bearings to try and get that clearance over 2007 inch, and I don't have the bearings yet. So that's where we're stopped right now. And the next clip, we will be doing that, and then we're going to go ahead and assemble this engine. Finally, we've done enough measurements. The only thing I haven't mentioned, and we'll do that on next time, is I got it right here, measuring end gap in the piston rings. But we'll cover that when we do the assembly. Thank you for watching Gold's Garage, and hope you found it helpful. Let me know in the comments if there's any other things that I missed. Be happy to respond to them. Thank you for watching.